Alright, chemistry. We got some reviewing to do. Um, we're back from break. I hope that everyone had, like, some kind of restful or relaxing break. I tried to. I slept quite a bit. Wrecked my sleep schedule, so work this week is going to be rough, but it's okay. We're gonna make it through. Um, let's get kind of back to this. I know that we have a little bit of notes to finish out a little later this week, but I figured it would be worth going through almost all of this. Um, I have my little cheat sheet answer key present, but I'm going to do this as kind of real time as I can here. I just ripped the pages from the assignment, and I'll go through the questions here. I have the numbers list in front of me, so I can do that while I have the questions on screen. Now, a funny thing should have happened when you got to page 21. A lot of it should have been done. All of it should have been done. We've done this page before already. That model of the atom that pictured the atom with electrons traveling in circular orbits. Planetary model. Compared all the way down to question 3, because I skipped 2. Compared to the entire atom, the nucleus is smaller with most of the mass. Famous experiment, positively charged particles were aimed at a thin sheet of gold foil, and it showed a few were repelled, so we have a positive core. Number 5, neutral atoms must contain equal numbers of protons and electrons. Which of the following is true of a compound, but not of a mixture? The composition of a compound does not vary. The composition of a mixture could vary. Right. Number 9. All isotopes of neutral atoms of sodium have 11 protons, 11 electrons. And there are 3 isotopes of hydrogen, H1, 2, and 3. All of them have an atomic number of 1. Those all should have been right in the context that, like, we've done that page already. So if y'all didn't know what to do there, you might be in a little bit of trouble. All right, let's move on. Page 54, or sorry, page 43. Looking at number 1. I need the chemical formula for iron 3 sulfide. Iron 3 means iron with a charge of +3. Sulfide is sulfur. And then I do my crisscross shortcut. I get Fe2S3. Number 5. If I need a compound, I need multiple capital letters. That's choice 3. Number 9. 2 substances combine for a single product. That's a synthesis reaction. Number 12. I've given you this question before, 100%, on at least one quiz, maybe 2. Maybe a quiz and a test. Oh, there we go. All right, it wasn't moving. Number 13, what is the IUPAC? Remember, if you see IUPAC, you can kind of just not worry about it. What is the name for this thing? It is zinc oxide. Given a balanced equation, what's the mass of water produced when 10 grams of this combined with 80 grams of this? Number 14 didn't look like it, but it was a conservation of mass question. If you have 10 grams and 80 grams at the beginning, that's 90 grams. Conservation of mass says we can't make any more, we can't lose any. So if there is 90 at the beginning, we have 90 at the end. Number 16. I've given you this question before also, but it was a short answer. N2O5 is dinitrogen pentaoxide. So it does look like they got rid of that A. They called it pentoxide. I would take pentaoxide. I don't worry too much about the spelling there. Which of the following is a synthesis reaction? We just said that you need one product. There's only one answer with one product. That was choice 2. Number 20. Here's an unbalanced equation, so I need to balance this, which means that I need a 2 here to balance out the magnesium, and I need a 4 here to balance out the chlorine, which means the coefficient was 4. Now, we're getting into some free response, some short answers. Number 23 asks you to write the formula of the compound produced, which is copper 1, sulfide. And then I have to crisscross these, which means I have Cu2S. That's the chemical formula there. Number 27 talks about this little, there we go, this little passage. During an investigation, a dripless wax candle, words, words, words. Physical change, the wax is melting. Chemical change, there's burning. The only thing to really be careful of here is just make sure you know which question you're answering. Read the question appropriately, right? Number 29 had you balance the equation. Now this is not the world's greatest version because there was hydrogen and oxygen and it was difficult to leave them until the end. So I apologize that this question was a little weird and wacky, but if you balance the hydrogen you got there. There were 12 on the left, so you needed 12 on the right, and then you would have fixed everything else. And then identify the type of reaction. This is decomposition, right? We're taking one thing, we're breaking up into multiple things. All right. Now, oh. All I want to do is move around. There we go. All right. We're on to page 55, where we're looking at question 1. A mole. All right, so these straight definition questions of what a mole is, which is a number of particles, right? A dozen is 12. A mole is 6.02 times 10 to the 23rd. And number 3, where the mass of the mole of a substance is equal to the GFM. Those kinds of definition questions are kind of nice. You should hope to see those because they're very straightforward. My goodness. My computer does not want to cooperate right now. I'm not sure why. I'm just going to check something quickly. Nope. That's cool. Alright. Don't know. One take. Do all this in one take. So, there we go. Alright, question number 4. Hydrated crystal. So we did that lab with the hydrated crystal. Hydrated implies that there are water molecules in the crystal. Number 8. The mass of a mole of oxygen. Well, the mass of oxygen is 32. A mole means 32 grams instead of 32 atomic mass units. There we go. The mass of a mole of CaOH2, again, just be very careful adding together all these things. It's calcium, 2 oxygens, 2 hydrogens. That's 74. 8, 10, number 12. What's the total number of moles in 80 grams of this thing? Well, number of moles is the given mass over the GFM, which is about 1.24. So that's choice 2. That's an equation that's on your reference table. So it's mole calculations. It says that the number of moles equals the given mass or the measured mass divided by the GFM of that compound. So they're telling us our given mass is 80 grams, and they tell us the GFM is 64.5. So given mass divided by the GFM, that gives us the number of moles that we have. Number 16, all the way down here. We need the GFM for glycine. This says you need the setup and the result. It might be a little difficult to do while typing, so I'll accept just the result. Glycine is this compound here, and it has a GFM of 75. If you add everything together. Again, I recommend caution. Like, you can do it, just don't do it too quickly. Number 18 here tends to prompt a lot of questions because a lot of times students will say, I don't know what propane gas is. Well, look at the equation. This is not propane gas. This is not propane gas. This is not propane gas. So it must be C3H8. You can use your process of elimination. You have more than enough ability to, I trust you, right, to make these conclusions. So the GFM for that, 3 times 12 is 36, plus 8 is 44. There's the GFM. Number 21, again, it's balancing. I gotta put a 2 here. Number 24, skipping around it. One day. Oh, there, it moved. It moved on its own. but it's stuck now. Hold on. There we go. Number 24. The equation can be correctly balanced by placing coefficient 2 in front of one of the formulas. That was actually this one. But it says give the proper name. So give the name of that. It's sodium hydrogen carbonate. Sodium because Na, and then HCO3 is one of our special polyatomic ions. Finally, we have 28 and 29. I know I'm not going to show you the proper numerical setup, but I think that you should be able to do it. This is, so here is ascorbic acid. Percent composition of oxygen. So percent composition equals the mass of the part, which is 6 times 16, because there are 6 oxygens, divided by the mass of the whole thing. Alright, I really hope I muted that. I'm so sorry if I didn't. The mass of the whole thing was 176. And then you need to multiply by 100. Then, the empirical formula for ascorbic acid, C3H4O3, because you take all of the numbers and you reduce them down as far as possible. There's going to be an empirical formula question. I guarantee it. I made the test, so I can tell you stuff like that. I can't tell you what I'm going to make you, either identify or create the empirical formula for, but keep in mind that, the empirical formula means take the subscripts and reduce them down as far as possible. Right? Finally, the last little section, 74 to 75. What properties does CO2 G? So don't forget what this means. This G means it's a gas. That's no definite shape, no definite volume. I'm not buying what you're selling. Please stop calling here. We're doing so well. All right. Number 4. I need a statement that describes the molecules of water in the solid phase. Solid phase means they are a regular geometric pattern. It just means that they're exactly in perfect spots. Oh, I forgot number 3. No, I'm looking at the wrong section. Number 5. Temperature rises, average kinetic energy increases. Temperature is average kinetic energy. All right, number 7. I need definite shape, definite volume. That's the solid. That's choice 3. It wouldn't matter what the compound is. The solid is the one that's going to have the definite shape and volume. Heat energy. Energy is measured in joules, and I believe that we mentioned that a little while ago. If we didn't, I apologize, and that's something that I'll negate it. We won't worry about it. But heat is measured in joules. Energy is measured in joules. All right. What represents an increase in average kinetic energy? Well, that means that temperature has to be increasing. So temperature has to be going up. So this section, and this section show increases in average kinetic energy. So not that one, not that one, and not that one. It's got to be choice 2. Just reading, right? Can you recognize where the average kinetic energy, the temperature, is going up? And just a handful more questions. What Celsius temperature is equal to 323 Kelvin? Well, Celsius plus 273 equals Kelvin. So subtract 273, you get 50 degrees Celsius. Number 15, left to right, increasing distance between molecules. So they need to get further apart. That's solid, liquid, gas. And the last 3 questions, so the last 3 on the page. Identify each mixture as homogeneous or heterogeneous. So mixture 1 is a colorless liquid with no visible solid. That's homogeneous. Mixture 2 has a black solid, so I can tell the difference. Heterogeneous. Density is mass divided by volume. What's the volume? So density is mass divided by volume. I know the density. I know the mass. So if I do mass divided by density, oh, I did this math. It's 2.02 grams per, nope, that's wrong. I need the volume, just centimeters cubed. Finally, what can I do to physically remove the water? Evaporation. I can evaporate the water away. That goes away. That's a physical change because I'm not changing what the water is, I'm just changing what phase it's in. That's a physical change. Alright, now, good news, right? No big official work. Hopefully you were checking your answers along with me here. Hopefully you did fairly well. Bad news, we have a little bit more notes to do. So we are going to finish the mole on Thursday/Friday, depending on which group you are. Quick note, if you didn't see it in the announcements, and hopefully you stuck around to the end of the video, Group 2 is like the lead group now, and Group 1 is the follow group. So any fully remote students, you should follow all the Group 1 instructions now, and Group 2, know that you're going to be ahead of Group 1 now. So because we started on like F2 day, now F2 and A1, those are my linked days. So Group 1, you're going to be quote-unquote behind. You're going to be the follow group now. That'll last until midterms. We'll see, I think after midterms it'll reset, so Group 1 will be the lead group again, but just changing it up a little bit, alright? I will catch y'all on Thursday. Like I said, we will be starting the last new part of moles, and then we'll get back into a little bit of review. Keep in mind there will be a review test coming up towards the end of next week. I'm thinking like Thursday or Friday next week. I think it's the 14th or 15th. It'll be online. It'll be timed. It'll be very similar to what you'll see. It'll be a shorter version of the midterm. I'll probably only make it half an hour, so it'll be half as many questions. It'll be half as long, right? So try to gauge your time based on that. Do the best you can. But more on that as we keep reviewing, all right? I will see you kids. Be safe. Take care of yourselves. Until Thursday or so.